so our goal here is going to be to solve radical equations, but before we get into any radical equations, I want to start off by taking a look at some things that we've done in the past, right? So these are all equations that we've seen before, that we've solved before, and so we're going to try to see what's kind of the pattern that we keep following when we're solving different types of equations. So we start off with number one. This is the most basic equation, a linear one, and in this case, what your goal really is to get the x value alone, right? And then we've solved the equation. So in this case, just subtract 10 and we get that 3x is equal to 30, right? And then divide both sides by 3 and we get that x is equal to 10. We've isolated that x value, right? Kind of traveled all the way down and we've isolated it and we're done. Okay, so when we take a look at the second problem, absolute value, going back to Algebra 1, we did learn about this. Okay, our goal was the same, except when we got to the end, we had a little bit more work to do. Our goal was to isolate the expression that contained the x value, which in this case is this entire absolute value bar. So in this case, if you notice, if I were to just kind of treat this entire highlighted area like my x in the above problem, it's going to kind of act the exact same way. We're going to just isolate that by first getting rid of addition and subtraction, which in this case I have a minus 20. So let's get rid of that. Okay. If I add 20 over, it looks like now it says 70, right? And again, I'm going to just keep pretending like that absolute value bar here is like x, right? So now this says 2x equals 70. So what I do in this case is I divide both sides by 2. Okay, and it looks like now I have that the absolute value of x plus 4 is equal to 35, right? And then we had some new method that we had to introduce for absolute value with how do we get it out of the absolute value bar. And in this case, we just said give the positive and negative versions on the other side, right? Because really when you take the absolute value, you can plug in a positive or a negative and get that positive 35. And then we proceeded as we normally did, right? So solve each of these, right? But the idea was that we just treated the expression that contained absolute value, that contained x, just like we did x. We tried to isolate that expression, right? So if I come over here to my quadratic, same thing. Here's the expression that contains my variable that I'd like to solve for. So I'm going to isolate that first by getting rid of addition and subtraction. So it's going to say 4 times x plus 5 squared. Add the 3 over. Now it says 36. I'm going to divide away what's attached to my expression that I'm trying to isolate. So I'm going to divide both sides by 4. And I get that x plus 5 squared equals 9. And then again, we had to think about some new way, like how do we get rid of a squared if I'm trying to get I'm trying to get x alone. And we had this way, we said let's square root away a squared. And then we ended up with x plus 5 is equal to, well, the square root of 9 could be 3, and the square root of 9 could be negative 3. And then again, we proceeded as normal and we got our answer, right? So if you see the pattern that's happening here, in each of these problems, we're trying to isolate x, or we're trying to isolate the expression that contains x. And when we solve each of these more complex ones, we're doing it the same way. In the first problem, we got rid of addition and subtraction. Then we got rid of multiplication and division. In the second one, we did the same thing. In the third one, we did the same thing. So if I take a look now at radical expressions, I'm going to follow that exact same pattern. The expression that contains my variable in this first problem is the radical with the x underneath. So my job is going to be to isolate that. Make sure that that's the only thing on the left-hand side of the equation, which means this plus 7 is going to come over to the other side. I'm going to say the square root of x when I subtract 7 over is equal to 9. And again, now that we have x isolated, or the expression that contains x isolated, we have a new question, and that is, how do you get rid of a square root so that I can have x by itself? Well, the opposite of square rooting is squaring. So I'm going to square the right-hand side, or the left-hand side, which means I need to also square the right-hand side. So if I say that the square root and the squared cancel, now x is alone, and it's 9 squared, which is 81. So I'm going to say my final answer to this one is 81. And so if you notice, what happened was we followed the exact same pattern. We just got the expression that contained my variable alone, and then we needed a new way to solve that one, right? So if I go to my next problem, right down here, okay, I'm going to say that my left-hand side that contains y is already alone. There's nothing floating around outside of my radical. So at this point, I can square immediately. Right? So I'm going to say that 4y minus 5 squared and square root cancel, nothing else left on the left-hand side but my radicand, is equal to 10 squared, which is 100. I'm going to add the 5 over. Now it says that 4y is equal to 105. And then y in this case, well, 105 divided by 4 does not work nicely, so I'm just going to say 105 over 4 the fraction, okay? Which might simplify, but, for our purposes, we're just going to leave it as 105 over 4. Okay. Last problem, same concept. We're going to get the expression that contains my variable alone, and we're going to get rid of addition and subtraction first. So I'm going to say subtract over the 6. Now it says 2 times the square root of x is equal to 8. I'm going to divide away my 2, right? That's always second. The radical x is equal to 4. And then we said to get rid of a radical, to get rid of a square root radical, we're going to square both sides. And we find out that x is equal to 16. Right? So in all of these problems, we just followed the exact same method. Right? But when we did so, we treated that expression like an x, got rid of all the other stuff, and then we performed our square to get rid of it. Okay? So we have this possibility that we need to watch out for called an extraneous solution. So an extraneous solution is a number that appears to be a solution, but when you plug it back into the original problem, it actually doesn't make the left-hand side and the right-hand side equal. So we have to be careful that when we solve our problems that we actually take our answer, or what appears to be our answer, and we plug it back in. So here's a simple example. 3c, the square root of 3c plus 8 is equal to 2. So I'm going to start off by subtracting the 8 over. That's outside of my radical, and it's going to say the square root of 3c equals, well, when I do 2 minus 8, I get a negative 6. Okay. Now I'm going to square both sides, right? Square the left, and I need to square this entire expression on the right. Okay, and I'm going to get that 3c is equal to 36. And it looks like I can say now that c is equal to 12, right? I divide both sides by 3, and look, I have my answer, right? So watch what happens when I plug 12 back in. The square root of 3 times 12 plus 8 is equal to 2. Well, 3 times 12 is 36, okay, plus 8 is equal to 2. So remember what this means. When we talk about taking radicals that are already in an equation, this square root means the principal square root of 36. And remember, principal just means the positive square root of 36. So I'm going to say the positive square root of 36 is 6 plus 8 equals 2. Well, 14 does not equal 2. And so this is what we would call an extraneous solution. I plugged it in, and I did not get a solution. A solution means the left and the right should be the same, and that is not true. So in this case, I'm actually going to say there is no solution to this problem. Okay? So I can try that. That can show up in all different types of problems. So let's try our second one. If I square, right here, if I'm looking at the right-hand side, I'm saying that's already isolated. My radical's alone, which means I can square both sides. So if I square the left-hand side, and I square this whole expression on the right-hand side, I get that a squared is equal to, well, squared and square root cancel, a plus 12. Okay? So I have a squared in my problem. It looks like I need to set it equal to 0, so I can use what I know about quadratics. I'm going to subtract the a and the 12 over to the left, and it's going to say a squared minus a minus 12 equals 0. This is a nice factorable expression. It factors into a minus 4 and a plus 3 equals 0. I can set each of those answers equal to 0. Okay? And I get my two solutions, 4 and negative 3. Okay, so let's check each of these. I'm actually going to get rid of this last problem because we are not going to do it, but I'm going to save myself the space. Right? So what we need to do now is check each of these answers and see if they are actually going to make the left-hand side and the right-hand side equal. So let's start off with my original problem. Let me get rid of all this stuff that I added in. Okay, my original problem says that a should be equal to the square root of a plus 12. So let's check. All right, if I plug in 4, it looks like it says 4 is equal to the square root of 4 plus 12. Okay, so 4 plus 12 is 16. So is 4 equal to the principal square root of 16? Remember, the positive square root of 16 is 4. That one worked out, so I'm going to say 4. That's a good answer. Okay, let's check negative 3. Negative 3 is equal to the square root of negative 3 plus 12. Negative 3 is equal to, this says the principal square root of 9, which is the positive square root of 9. Well, the positive square root of 9 is 3. And I'm saying that 3 is equal to negative 3, which is not true. So I'm going to get rid of this answer and say I have one solution to my problem, and that is that A is equal to 4. And that is my only solution because negative 3 was extraneous.